Commodore Group of Schools online classes. So in previous class we learned how to find the zeros of a polynomial by using graphs, and also we learned the zeros of a polynomial of a linear polynomial by using graph, and also we have learned how to find the zeros of a quadratic polynomial by using graph. Now we will see another example of the quadratic polynomial. So take another example. So find the zeros of p of x is equal to 6 minus x minus x square. 6 minus x minus x square by using graph. So we know that first we have to equate the given polynomial to some y. So let y is equal to 6 minus x minus x square. So that is the given polynomial. And if you observe, this is not in the general form. So first we have to write it in general form. General form is nothing but it must be in the form of ax square plus bx plus c. So first we have to write the x square term, then x term, and then constant. So we can write this as, so y is equal to, we can write first x square term, that is minus x square, then after that x term, and then finally we have to write the constant. Now this is the general form of a quadratic polynomial. To find the zeros of this polynomial, first we have to know the coordinates, that is x coordinate and y coordinate. To get that, we have to take the table. And also we have to substitute the x values, and then we will get y values. So we can take any x value, any x as a real number. So if I take x values as minus 3, minus 2, minus 1, 0, 1, 2, and 3. So I am taking 3 negative values, 3 positive values, including 0. So we can take any value. So I am taking this one. And if you substitute that x values in the given polynomial, then we will get y value. So if you substitute x is equal to minus 3, then we will get y value. So here here 3 terms are there. So first we have to write the 3 terms separately. So minus x square, that is the first term, and second term is minus x. Then after that we have to take the constant. Now substitute x values. So if you substitute x is equal to minus 3, here minus is there. So first we have to take minus, and in place of x we have to write minus 3. So minus 3 whole square, we will get 9. So we will get totally minus 9. Similarly, the second one is, here minus is there, minus first we have to write. Then in place of x, if you substitute minus 2 whole square, it becomes 4. Similarly, if you take minus 1 in place of x, so here minus first we have to write it as it is. Then after that, in place of x, if you substitute minus 1 whole square, we will get 1. Then again, if you substitute 0, we will get 0. Then after that, in place of x, if you substitute 1, so 1 square is 1, here minus is there, so minus 1 you will get. Similarly, in place of x, if you substitute 2 square, and minus means we will get minus 4. Similarly, minus x square. So in place of x, if you substitute 3, then you will get minus 9. Similarly, here in second term also we have to substitute the x values. So here already minus is there. Minus into minus plus, and in place of x, if you substitute, you will get plus 3. Similarly, if you substitute x is equal to minus 2, so minus into minus plus 3. So 2 into x, that is in place of 2, if you substitute, you will get 2. Similarly, minus 1, if you substitute in place of x, minus into minus plus, so in place of x, if you write 1, we will get 1. So similarly, here we will get 0. Then after that, if you substitute 1 in place of x, you will get minus 1. Similarly here, minus 2. Then after that, minus 3. Now, this is the constant. So here we don't have any x value to substitute. So we have to take all values as 6. There is a constant, so we have to write 6 as it is. Then after that, if you add these 3 terms, we will get y value. So finally we have to take y. So this is y. So to get y, we have to add these 3 terms. So minus 9 plus 3. Minus 9 plus 3. How much it is? It is minus 6. Minus 6 plus 6. So we get 0. Similarly, 6 plus 2, 8. 8 minus 4. 8 minus 4 is we will get 4. After that, 6 plus 1, 7. 7 minus 1, again we will get 6. So if you add this 3, 6 plus 0, so you will get 6 only. Then after that again, 6 minus 1 is 5. 5 minus 1 again, you will get 4. Here, 6 minus 4 minus 2 is minus 6. Minus 6 plus 6, you will get 0. Then after that, and last one is minus 9 minus 3. Minus 9 minus 3 is minus 12. Minus 12 plus 6, you will get minus 6. Minus 6. So, if you substitute x values from real numbers, we will get y values. And if you write it in order pairs, then the coordinates what we will get is, therefore, the coordinates are, so what are the coordinates we will get? So, x is equal to minus 3, then y value is 0. So, we can write it as minus 3 comma 0. Minus 3 comma 0. Similarly, minus 2 comma 4. Then after that, minus 1 comma 6. Then 0 comma 6. After that, 1 comma 4. Then 2 comma 0. And finally, so if you take x as 3, then you get y as minus 6. So these are the coordinates we got. Now if we plot these points on the graph, then we'll get graph paper, then we'll get the graph. So horizontal line, first we have to take it as x-axis. Then after that, this is vertical line and it is y-axis. Y-axis. And this is negative x-axis. This one is positive and negative y-axis. And the intersection of x-axis and y-axis we have to take it as 0. Now take the real numbers on the x-axis and y-axis. So if you observe here, the x coordinates are up to maximum positive values are 3 and negative values are minus 3. So we can take on x-axis, we can take 1 centimeter is equal to 1 unit. Similarly, negative, that is minus 1, minus 2, minus 3, minus 4, and we can take up to minus 4. Then on y-axis, the highest value is 6. So and negative value is also 6 is there. So we can take here 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. Now plot all these points on the graph. Then minus 3 comma 0. Minus 3 is on x-axis and 0 is on the x-axis. So here the point is minus 3 that we will get on x-axis. Now similarly minus 2 comma 4. Minus 2 I have to take on x-axis and 4 is on y-axis. The intersection of the 2 points, that is minus 2 and 4. So we will get that point. And let it be this as minus 3 comma 0 and this as minus 1 comma 4. Then after that, minus 1 comma 6. So minus 1 and 6. So the point will be here. This is minus 1 comma 6. Then after that, 0 comma 6. 0. 0 is here and 6 is on y-axis, positive y-axis. So here it is 0 comma 6. Then after that, 1 comma 4. 1 x-axis and 4. So we will get the point here. This is 1 comma 4. And the next one is 2 comma 0. 2 comma 0 on x and positive x-axis we will get. Similarly 3 comma minus 6. So 3 and minus 6. So finally we will get this point. 3 comma minus 6. And if you join all these points, then we'll get a graph which is also a curve, and also this curve will call it as the parabola. Already we learned it. So the graph of a quadratic polynomial, which is nothing but parabola. Now if you observe, in first example, we got the graph as, we have taken the polynomial p of x is equal to x square minus 5x plus 6. So for this graph, we got the graph parabola which open on upwards. So we got like this. But if you observe this example, in this example, we are getting the parabola which is open downwards. So here for these two graphs, we are we have some difference. So this one in this graph, the graph open upwards, and for this graph it is open downwards. So what is the difference between these two is, so if you observe these two examples are two polynomials, x square minus 5x plus 6, this is the last class we have learned the graph. Now here the given polynomial minus x square minus x plus 6. If you observe these two polynomials, and if you observe the coefficient of x squares, here the coefficient of x square is 1, which is positive value, and here the coefficient of x square is minus 1, which is negative value. So what we can conclude is, if the x square coefficient is positive, if a is positive, that is greater than 0, then we will get the parabola, which is parabola which open upwards. Similarly, if a value is less than 0, that is, you will get negative coefficient of x square, and if a value is less than 0, again you will get parabola only, but which open downwards. So what we can conclude is, if ax square plus bx plus c is a quadratic polynomial, and if a value is greater than 0, then the graph of that quadratic polynomial will get parabola and also which open upwards. And if ax square plus bx plus c is of a quadratic polynomial, if x square coefficient is less than 0 or negative, then we will get the parabola shape only, but it open downwards. So here ax square plus bx plus c is a quadratic polynomial. Now for this quadratic polynomial, if a value is greater than 0, we know that we will get parabola, and that parabola also open upwards. Similarly, if the polynomial ax square plus bx plus c, for this quadratic polynomial, if a value is less than 0, and if you draw the graph of this, we will get parabola and then which open downwards. So just we have learned these two graphs. Now if you observe the quadratic polynomial, if you draw the graph, we have three cases of possibilities. We have three possibilities to get a graph. So in that, the first possibility is so if you draw the graph of ax square plus bx plus c, p of x is equal to ax square plus bx plus c, and if a is greater than 0, this is very important. So if a is greater than 0, then we have three possibilities of getting the graph. In that, if you take the first one, that possibility is, let it be y-axis and this as x-axis. And this one has y-axis, and this is negative x-axis, this is negative y-axis, and let it be the origin. And the first case is, the graph may be cuts the x-axis at two different points. So the first case is, so if ax square plus bx plus c in this, if a value greater than 0, so one of the possibilities is the graph may be cuts the x-axis at two different points. So this is one point and this is another point. Let it be a and this as a dash. So if this graph cuts the x-axis at two different points, then we know that we will get two zeros. So here the graph cuts the x-axis at two different points. So if graph cuts the x-axis at two different points, then we will get number of zeros. Number of zeros are 2. We will get 2 zeros. Similarly, another case is there. So in second case, Case 2. If ax square plus bx plus c, which is a quadratic polynomial, and if a greater than 0, we can get the graph. If we draw the graph of that quadratic polynomial, we can get another possibility is the graph may be touch the x-axis at only one point. So this is one of the possibility to get like this, the graph. So here the graph cuts the x-axis at only one point. So this is x-axis and this one is y-axis. So in second case, the graph may be cut the x-axis at only one point, but it is a quadratic polynomial. So how many zeros we have to get? We have to get 2 zeros. But here the graph cuts the x-axis at only one point. So what we can conclude is, we should not say that it has only one zero. We have to conclude that it has 2 zeros of equal values, or 2 equal zeros we will get. For example, if x is equal to 2, another value is also 2 only. So we will get the equal zeros. So here the graph cuts the x-axis. The graph cuts the x-axis at only one point. So here what we can conclude, therefore it has, so it is a quadratic polynomial, so definitely we have to get 2 zeros. So the 2 zeros must be coincides. That is, it has 2 coincide zeros. So both the values are same. Similarly, in third case, we have another possibility, that is, this is x-axis and this one is y-axis. And if you draw the graph of the quadratic polynomial, if a is greater than 0, another possibility is that graph maybe does not touch the x-axis. It does not touch the x-axis. So this is also one of the possibility. So first possibility is the graph cuts the x-axis at 2 different points, and in second possibility the graph may be touched at only one point, and in third possibility the graph it does not touch the x-axis. If it does not touch the x-axis, then what we can conclude? We can conclude that, so we will get the zeros only if the graph cuts the x-axis. But here the graph does not touch the x-axis, so we can say that it has no zeros. So here the graph does not touch the x-axis. Therefore, we can conclude that it has no zeros. So, if ax square plus bx plus c is a quadratic polynomial, and if a greater than 0, then we have 3 possibilities of getting the graph. In the first possibility, the graph may touch the x-axis at 2 different points. So if it touches the x-axis at 2 different points, then we will get 2 zeros. Similarly, in this case, if you observe, the graph cuts the x-axis at only one point. So here also we will get the 2 zeros, but both the zeros are same. Equal zeros you will get. And in third case, the graph does not touch the x-axis. If it does not touch the x-axis, then we will get no zeros. So this is one of the possibilities. And similarly, if for the quadratic polynomial, if a value is less than 0, coefficient of x square, if it is negative, less than 0 is nothing but it is negative, then what happens? So here also we will get 3 possibilities. In the, if you observe the first case, case 1, and if you take x-axis and y-axis, this is x-axis, the vertical line we got it as y-axis. So let it be origin. Now, if a value less than 0, here also we will get again 3 cases. In the first case it may be the graph may cut the x-axis at 2 different points, but we will get the graph which open downwards. Now here also the graph cuts the x-axis at 2 points. This is a and let it be a dash. So here also what we will get? Here also we will get 2 zeros, and that so here the graph cuts the x-axis at two distinct points. So what we can conclude, therefore, it has two different zeros. Similarly, here also, if you take the second case, in second case 2, if you draw the graph of this quadratic polynomial and if a less than 0, then we will get another possibility. This has x-axis and this one has y-axis. And if you draw the graph of that, then it may touch the x-axis at only one point. So let it be, take this as the graph. Here also we will get again parabola only, but which open downwards. Now here the graph cuts the x-axis at only one point. So what we can conclude, here the graph cuts the x-axis at only one point. So what we can conclude, therefore, the number of zeros are 2 and both the zeros are same. So here number of zeros are 2 of equal zeros. So equal zeros will get. So both the zeros are same. Similarly, here also in third case, if you take x-axis and y-axis, and if you draw the graph of that polynomial, then the third possibility is that it does not touch the x-axis. So let it be this one. So here the graph does not touch the x-axis. So what we can conclude, if it does not touch the x-axis, we can say that it has no zeros. So what we can write here, the graph does not touch the x-axis. So if it does not touch the x-axis, then we can conclude that it has no zeros. So totally we will get 6 possibilities. 3 if a greater than 0, another 3 if a less than 0 of a quadratic polynomial ax square plus bx plus c. Okay. Up to now we learned how to find the zeros of linear polynomial and quadratic polynomial by using graph. Now we will see how to find the zeros of the cubic polynomial. So we know that if it is a cubic polynomial, we have to get 3 zeros because it depends on the degree of the polynomial. If the degree of the polynomial is 3, we have to get 3 zeros. Now we will see, we will take one example. Find the zeros of p of x is equal to x cube minus 4x. So we will take the polynomial x cube minus 4x, and if you observe, the degree of this polynomial is 3. If the degree is 3, then it is a cubic polynomial and we have to get 3 zeros. Now we will see how we will get the 3 zeros. Now first, let y is equal to x cube minus 4x. So we have to plot the points, we have to know x and y coordinates. So to get that, take the values of x, some real numbers. So this is x values. So here we can take minus 2, minus 1, 0, 1 and 2. So we are taking the x values as minus 2, minus 1, 0, 1. We can take any real number. So here we are taking these values. And if you substitute in these values, then we will get y value. So before that, x cube. So how many terms are there? 2 terms are there. So take the 2 terms like this. X cube and next term is minus 4x. Minus 4x. Now x cube is nothing but, so in place of x I will take minus 2. So minus 2 whole cube will get minus 8. Similarly, x cube in place of x, if you substitute minus 1 whole cube. So power is odd number, so we get negative only. So x cube is nothing but minus 1 whole cube, which is again minus 1 will get. And then if you substitute in place of x as 0, so 0 cube, that is 0. Similarly, if you substitute x is equal to 1, we will get 1 cube as 1. Then if you substitute 2, 2 cube will get 8. Then again in second term minus 4x is there. So minus 4 into x is nothing but minus 2. So minus into minus plus 4 2s are 8. Then after that again if you substitute x is equal to minus 1. Minus 1 if you substitute, then minus into minus plus 4 into 1 will get 4. Then after that if you substitute 0, minus 4 into 0 it becomes 0. Similarly, if you substitute in place of x as 1, minus 4 into 1 will get minus 4, and then if you substitute. So here we have to find y value. How will you get the y value? By adding these two terms. So minus 8 plus 8. So if you add it, you will get 0. Then after that, minus 1 plus 4. Minus 1 plus 4 will get 3. Then after that, 0 plus 0 will get 0. Then 1 minus 4 is minus 3. Then after that, 8 minus 8 is 0. Now we have to write the ordered pairs. Ordered pairs means x and y coordinates. So if I write the ordered pairs, the coordinates are what are the coordinates? Minus 2 and 0. Minus 2 comma 0. And then second one, minus 1 comma 3. After that, 0 comma 0. Then 1 comma minus 3. After that, 2 comma 0. So they are the coordinates. So this is x coordinate and y coordinate. Now we have to plot all these points on the graph to get the zeros. This is x axis. Y axis. So on x axis and y axis, the intersection part we have to take it as 0 or origin. Now on x axis and y axis, we can take 1 centimeter as 1 unit because all they are smaller values of it. So we can take, so on x axis 1, 2, 3, 4 and 5. 1 centimeter is equal to 1 unit I am taking. Similarly here also minus 1, minus 2, minus 3, minus 4. So here negative value is minus 1, minus 2, minus 3, minus 4 and this is minus 5. Similarly on y-axis, positive y-axis 1, 2, 3, 4, 5 and 6. Now plot all these points on the graph. So the first one is minus 2 comma 0. Minus 2 and 0 means you will get on x-axis the point. Minus 2 comma 0. Then after that, minus 1 comma 3. Minus 1 and 3. So that is the point. Minus 1 and 3. Then after that, 0 comma 0. 0 comma 0 which is nothing but origin. Then after that, 1 comma minus 3. On x-axis 1 and y-axis minus 3. So intersection point is this one. So it is 1 comma minus 3. Then after that, 2 comma 0. 2 comma 0 which is nothing but we will get on x-axis. 2 comma 0. Now, if you join all these points, we will get the graph like this. Now, if you observe this graph cuts the x-axis at 3 distinct points. So, this is one point, minus 2 comma 0 is one point, and origin is nothing but 0 comma 0. So, 0 comma 0, this is another point, and 2 comma 0, that is third point. So, here the graph cuts the x-axis at 3 different points. So, we will get 3 zeros. So, what we can conclude here? So, here the graph cuts the x-axis. The graph cuts the x-axis at 3 points. At 3 points. What are the points? Minus 2 comma 0. Another point is minus 1 comma 3. And then, sorry, x-axis 0 comma 0. And third point is 2 comma 0. 2 comma 0. So minus 2 comma 0, 0 comma 0 and 2 comma 0. So these are the 3 points which cuts the graph on x-axis. So what we can convert? So in these points we have to take only the x coordinates and we have to say that they are the zeros of the polynomial. So here the zeros of the cubic polynomial. The zeros of the cubic polynomial are, what are that? In this, the x coordinate is minus 2, in this x coordinate is 0, and in this x coordinate is 2. So they are the zeros of the cubic polynomial.